Hello, welcome back to our channel where we simplify data science concept for everyone. In our last video, we have explored univariate analysis, looking at single variable in isolation. Today we are diving into fascinating world of multivariate analysis where we analyze multiple variables together to uncover deeper insight. We will be using real world example, so make sure you stick around. So let's start with the basic. Multivariate analysis is a collection of statistical techniques used to analyze data that involves more than one variable, while univariate analysis focuses on understanding a single variable. Multivariate analysis helps us to explore relationship and pattern among multiple variables simultaneously. For instance, instead of just looking at someone's age, we might look at their age, income, and education level together to understand their spending behavior. So, by this, we can give them a product to purchase. So, why should we care about multivariate analysis? In real world scenario, outcomes are really influenced by just one factor. For example, let us say you are working in a data as a data analyst in a car dealership. You want to predict car sales. If you have only look at the car price, which is univariate analysis, you are missing out on crucial factors such as car brand, fuel efficiency, customer demographic. By analyzing these factors together, we can make more accurate prediction and better understanding the complexity of world around us. Multivariate analysis comes in a many form, each tailored to different kind of data and research question. Here are some of the most commonly used techniques along with the example to help you understand. Multiple regression, principal component analysis, factor analysis, cluster analysis, and multivariate analysis of variance. First, multiple regression. This technique examines how multiple independent variables influence a single dependent variable. For example, predicting a student's GPA based on their study hours, sleep, and class attendance. Second, principal component analysis (PCA). PCA reduces the dimensionality of data while retaining most variability, making it easier to visualize complex data sets. For instance, in genetics, PCA might be used to simplify analysis of thousands of gene expressions to identify key factors. Third, factor analysis. This technique identifies underlying relationship between variable. A classical example is in psychology, where factor analysis might be used to identify underlying traits like introversion or extroversion from a set of survey response. Fourth, cluster analysis, used to group similar data points together. For example, in marketing, customer might be clustered based on their purchasing behavior, allowing companies to target specific group with tailored marketing strategy. Fifth is multivariate analysis of variance, similar to ANOVA but used when there are multiple dependent variables. For instance, studying the impact of different teaching methods on student performance across multiple subjects. Multivariate analysis are widely used across various fields. Let us look at some of real world examples. First is marketing, second is healthcare, third is finance. Marketing. Imagine you are working for some e-commerce company. You want to segment your customer to offer personalized recommendation. By analyzing the browsing history, purchase frequency, and average spend, you can group them into distinct segments like budget shoppers, luxury buyer, and frequent buyers. Second, healthcare. Suppose you are a researcher studying the risk factor for heart diseases. By analyzing data on diet, exercise, genetics, and lifestyle, you can identify which combination of factors most strongly predict the risk of developing heart disease. Third, finance. Let's say you are a financial analyst trying to assess the risks and return of an investment portfolio. By examining multiple economic indicators like interest rate, inflation, and stock market trends, you can build more robust model to guide investment decision. Now let's see multivariate analysis in action with hands-on example. Using multiple regression, imagine you are data analyst for a real estate company and you want to predict house price. You have data on various factors like square foots, number of bedroom, neighborhood quality and proximity to school. By using multiple regression analysis, we can create a model to predict house prices based on these variables. So let's jump into the code. Okay, I am using Google Colab for this. You can use any software of your choice. So first of all, we will import necessary libraries. Libraries are like toolkit for our data analysis or machine learning process. So first of all, I will import pandas, then numpy, then matplotlib, and then seaborn, and then stats model. Okay, I will run this code. So pandas are used to manage the data in tabular form. Okay, numpy are used for mathematical calculation. Matplotlib and seaborn are used for plotting the graph. Okay, and stats model are used to statistical analysis like mean, median and mode, and standard deviation and covariance, etc, etc, etc. Okay, and then in second step I will load the data sheet. I already loaded, and I will show the process how to load. So first of all, you have to just copy the path and then just paste it here like this. Just a second, it is like, okay, control and V. Okay, you have pasted your file here, and that's just you have to run this and nothing else. Okay, you get the output. So pd.read is used to read the CSV file. df.head is used to display the first 5 rows of the dataset. You can see here. Okay, in third step, checking the missing values and get the basic statistics. Understanding the data is our aim. Without understanding data, we can't implement the machine learning model. Okay, so we will understand this data like you. Okay, so we don't have any missing values. Like df.isNull is used to detect missing values. Okay, and df.describe is used to find statistical methods like statistical properties like mean, median, standard deviation, maximum value, minimum value, etc. You can see here. And sns.histplot is used to plot the graph. You can see here. Okay, and in this step we will implement the regression model. So x is the factor which are influencing our price. Okay, like square foot, bedroom, neighbor quality and proximity to school. Okay, and sm.add is used to add interpreted. When all the values of all the factors are 0, then this is used to detect the or detect not. This is used to predict the price of our house. So y is the actual thing which we have to predict, which is price of the house. Okay, we will implement the machine learning model. Don't be scared from OLS regression. Okay, I will make much easier for you. Okay, what is dependent variable? The variable you are trying to predict. In this case, this is price. Okay, model indicate that you are using OLS method, which is ordinary least square for this regression. Okay, R squared. This is tells how well the model explain the variability in the price. And R squared of 0.983 means 98.3% of the variability in the price can be explained by this model. This is very high, This is very high. Okay, so we will see like square foot. For each additional square foot, the expected increase in price is $270 approximately. You can see the t value is 0.10. If the p value is less than 0.05, the quantities, the factors are relevant, otherwise they are not significant. Okay, like you can see here, neighbor quality. If the neighbor quality is increased, the price will decrease by 412, approximately $412. So this does not make any sense. So you can see the t value is greater than 0.05. okay, by this you can analysis the, okay, and then finally we will make the graph. Scatter plot is used to, in this graph, on the one axis it is actual price, and in other axis it is predicted price. Okay, you can see the dots are actual price and the straight line is predicted price. This example demonstrates how we can use multiple regression to predict outcome based on several factors. Even though this is just a basic introduction, it is a powerful tool that can be applied to many different fields. In next slide, we will explore more example to dive deeper into the world of multivariate analysis. Performing multivariate analysis can be straightforward with right tools. Here is quick guide. Data preparation. Ensure your data set is clean, no missing value. All variables are in correct format. Second, choosing the right technique. Depending on your goal, such as prediction or pattern recognition, choose the appropriate multivariate methods. For example, if you want to understand the relationship between variables, multiple regression might be the best bet. Third, running the analysis. Use statistical software or programming language like R, Python, or even Excel. For instance, Python's stats models library is great for regression, while sklearn is ideal for PCA. Fourth, interpreting results. After running the analysis, focus on understanding what the output tells about the relationship between variables. For example, in regression, look at the coefficient to see how each independent variable influence the dependent variable. So that's the wrap on our introduction to multivariate analysis. We have covered what it is, why it is crucial, and the different type, and walk through real world example. If this video helped you, give it a thumbs up, share it with your fellow data lovers, and subscribe to our channel for more insightful content. Don't forget to leave the question in the comment. I will be there to help you. See you in the next video. Bye bye. Thanks for watching.